Now, maths is not just in the classroom. Maths is all around us. And today what we're going to do is we're going to be looking at different little tricks, little puzzles, and so on, to enjoy a bit of maths outside the classroom. So the first thing I'd like you to do is to take out your whiteboard or your piece of paper, whichever way you're working, and we're going to do a little number sentence, and you're going to have a big surprise at the end. Well, hopefully you're going to have a big surprise. I would like you, on your whiteboard or in your piece of paper, I would like you to think of a number between 1 and 9. Now, this is a secret, so don't tell anybody else what you've got or what you're going to put down. So put down a number between 1 and 9. We're now going to do a very hard example, and that is we're going to add 1 to your secret number. We don't have to really write it down. You could do it in your head if you wish. With our new number, I would like you to multiply the number by 9. New number multiplied by 9. Add 1 onto your result. Add 1 onto your result. And so you should have a 2-digit number. I've been told mine is wrong because I thought 8 9s are 73, but I've been told that's wrong. Now what we're going to do is we're going to add the 2 digits together. So in my case, 7 plus 4 equals 11. Now hopefully you've got an even number. If you haven't got an even number, go back and see where you may have made a mistake. We are going to halve your new number. We're going to halve your new number. Don't tell anybody what it is. We are now going to change your number into a letter. So if your answer was 1, your letter is A. If your answer was 2, the letter is B, 3, C, 4, D. If your answer was 5, the letter is E. Your answer was 6, letter F, and 7, G. So it could be one of those answers. The next thing I would like you to do is think of a mammal, a warm-blooded animal, beginning with your letter. I don't want a reptile, I don't want a snake, I don't want a bird, I don't want an insect, I want a mammal. And now on the count of 3, I would like you to call out your named animal. 1, 2, 3. And I'm sure many of you got that as your answer, an elephant. Now you could have said 4 other animals which begin with the letter E. There's the echidna, which is an ant-eating animal, which is South American and parts of Asia, I believe. You've got the beautiful deer, the eland, from southern Africa, the size of a cow. You've got the ermine mink, very soft fur. And you've got the elk, which lives in North Europe and also in Canada. So there you are. Not only are you doing maths, we're doing a little bit of other subjects as well. So why or how does this work? Well, multiplying by 9 is always a very good number, because when you multiply by 9 and you add the 2 digits together, it'll always come to 9. And so if you add 1 to it, it becomes 10. So everybody got to the answer 10. We are now going to do an impossible example in 25 seconds. Well, hopefully we are. Here we've got a number line which goes from 1 to 100. And if I asked you, could you add up all the numbers, including the ones in the middle, which have disappeared? So 3, 4, 5, 6, 7, 8, 9, all those are all numbers. If I asked you to add all those numbers together, how long will it take you to do? It'll probably take me 15, 20 minutes. And if I use the calculator, probably the 27th number I put in, I make a mistake, and then I've got to go back again. But by the end of this little activity, you should be able to work it out within half a minute to a minute. So let's see how it works. Now in maths, when you've got a big problem like this, or a task, a challenge, then we need to think in small terms, small numbers. Mathematicians are quite simple and they like doing things in a very small way. So here we have 1 to 6. Now, if I asked you to add those numbers 1 to 6, I'm sure you could do that in about 25 seconds now. So could you add those up, please? And if I was adding these up, and if I was multiplying a list of numbers, I'd always start with the big number and then work to the small. So you go 6 plus 5 is 11, plus 4 is 15, plus 3 is 18, plus 2 is 20, plus 1 is 21. Now, if you play with dice a lot, you know that there are 21 spots on a normal dice. So now I'm going to show you an easier way than adding these up. Because if we look at the first digit and the last digit, we add that up and it becomes 7. If we look at the second digit and the second last digit, we add that up and it becomes 7. And if we add up the two center digits, that also becomes 7. So we now can say that we've got 3 pairs and each pair adds up to 7. So 3 times 7 is 21. And that's a very simple way of adding up a series of numbers. So what I would like you to do, and you don't have to write out 1 to 10, you may be able to work it out by just jotting a few things down, but I would like you to tell me what is the total of the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So try and work that out and see what we come up with. The first and last number adds up to 11. And then the next two numbers add up to 11. And that continues. And we find that we have got 5 pairs. So I'm sure a lot of you got 5 times 11, which was 55. So now I'm going to come back to this challenge. And you'll be surprised, a lot of you will be able to do it. I know I've started with quite a difficult thing to do, but I'm sure you'll be able to work it out. So I'm going to give you roughly a minute to work it out. The good thing is you're going to multiply by 100. So all you have to do is put noughts at the end, and you should be able to do it. Who's going to be the cleverest of us all and work out the total? So I know that the pairs of numbers add up to 101. We know that there are 50 pairs. The way I would do it is say 100 times 50. So that's the 100 times 50. And then we've got the 1, which we multiply by 50, so it's 50. So we add the two answers together. And hopefully, some of you have got it. And if you have, you've done extremely well, and well done. And the answer is 5,050. 5,050. What I'd like you to do now is take out your clock. Take out your clock. We're going to be doing some spelling. Now, whoever ever thought of this must have been very bored and must have been raining, but it's quite an interesting thing. If you start at, say, 1, we know that there are 3 letters in 1, O-N-E. So we now move 3 places in a clockwise position. 1, 2, 3. We are now at 4. We know that 4 has got 4 letters. So we go 1, 2, 3, 4. We have finished up at 8. 8 has got 5 letters. 1, 2, 3, 4, 5. Now, if we started at 3, for example, 3 has got 5 letters. So 1, 2, 3, 4, 5. We seem to end up at 8 there, but never mind. Let's look at 2. 3 letters. 1, 2, 3. Then 5 has got 4 letters, so you can move 4. What I would like you to do is I'd like to find out what number do we always seem to end at? What number do we always seem to come to? And if you're a good mathematician, you don't do it once, you do it several times. You may try 1 first of all, then you might try 2, and then you might try 7. And so I'm going to give you 2 minutes to go around the clock with the spellings and see what number you will come up with. See what number you come up with. So what sort of results are we getting? I'm going to start at 12, because that's an interesting one. 12 has got T-W-E, L-V-E. It's got 6 letters. So you go 1, 2, 3, 4, 5, 6. 6 has got 3 letters, 1, 2, 3. 9 has got 4 letters, 1, 2, 3, 4. 1 has got 3 letters, 1, 2, 3. So we're down to 4. 4 has got 4 letters, 1, 2, 3, 4. 8 has got 5 letters, and we seem to come back to 1. If you start at 10, you go straight to 1, and then you go through the same system. If you go to 9, you go straight to 1. And if you start at 8, you go straight to 1. So how are you going to show people or why it works? And the best way to do it is by creating a table. So we've created a table. So if we started at 1, it tells us to move 3 letters, 1, 2, 3. Then we go to 4, which is 4, 1, 2, 3, 4. And then 5, 1, 2, 3, 4, 5, which is 13, which of course is 1. And that's how you can show how it works. The person who thought of it, well, unusual, but it is a very interesting thing because of the letters of the words. Now we need our whiteboards out for this, and I'm going to make your eyeballs go all funny because we're going to do a couple of optical illusions. Optical illusions. There's a lot of maths in optical illusions because of the shapes, the shading, and the angles and so on. So first of all, I would like you to draw, there's no need for rulers or measurement, but try and draw as neat as possible, a square, roughly 15-20 centimeters big if it fits. Draw a square. With a similar size, I would like you to draw another square which is overlapping. Another square that is overlapping. Now, some people may know this, but if you add 3 or 4 more lines to this shape, you make a very nice 3-dimensional cube. So if you could do that. And if you keep looking at your cube, it changes direction. If you look at my cube, what I'm looking at is looking at the bottom of the cube and the front. Or should I say the side? Now I'm looking at the front and the back and I can't see the bottom. So it's playing tricks on my eyes. It's playing tricks on my eyes. And if you can't see the changes, ask somebody to explain it to you. Now we're going to add something onto it. I would like you to shade in. Doesn't have to be a masterpiece, just a few lines. Shade in one of the faces. And then have a look at it and see what's happening. And I'm sure things have changed. For me, it has definitely changed with that. Now we're going to put that to one side, and we're not going to draw it because it's quite difficult to draw, even with a ruler and measurements. But there is a hexagon, a regular hexagon. The sides are all the same. If I add a line to it, I've now created a new set of shapes with one set of parallel lines. So it is a trapezium, or in the plural, it's trapezia. If you go to the circus and you go and see the trapeze artist, that's come from the shape of their swing, where it's narrow at the top and wide at the bar that they hang on to. I am now going to add 2 more lines to create 6 equilateral triangles. But if you look at that shape, it's actually a cube. If you look at the shape, it's actually a cube. And again, it changes direction as well. And then you can't find the 6 triangles. The brain is working twice as hard today. If you can't see it, ask a friend to try and point it out. My cube is falling over. My cube is falling over towards me. Now, in 1899, a mathematician created the next illusion, and it's quite famous because there's a lot of books of illusions. And the question I'm going to ask you is, how many cubes were used to make this shape? How many cubes? I'm going to put you out of your misery. And you need 6 cubes. 6 cubes to create that. But it's very clever mathematically, the way they've shaded it. Because I'm sure lots of people said there were many cubes. We're now going to move on to the number square. And it doesn't matter if you're, well, it does matter, but some of your number squares have got different numbers to your friends. So you go onto your number square. Doesn't matter what you've got. There's one mistake on it. There's probably 2, but we'll see. Now, those people who've got a number square, which has got at the bottom, on the bottom line, it says 3, 4, 5, 9. 3, 4, 5, 9. I got an email from a year 5 boy the other day to tell me that's wrong. And he was right. So instead of the 5, could you write a 6? So the 3, 4, 5, 9 should be 3, 4, 6, 9. Now, as you can see, my number square is different from yours. And yours is probably different from your friends. So in theory, only a half of you will get it right, or I'm the only one that gets it right. So that is the theory, but let's see what happens. Then I'll explain to you why it did happen. First of all, I'd like you to draw a circle around one of the numbers on the top line. Draw a circle on one of the numbers on the top line. And what did I do? I think I circled the second block. We now cross off all the other numbers in that row. So we cross off the 3 numbers we haven't used. And likewise, we cross off the numbers which are vertical. So we can cross off another 3 numbers. We do it again on the second top row. I would like you to circle a number. In this case, I did the extreme right. Now I'd like you to cross off the numbers horizontally on the same line. And once again, I'd like you to cross off the vertical numbers. So you should be left with 4 clean numbers. In the third line, you'll never guess. Yes, put a circle around one of the numbers. Now, please remember your answer is going to be secret, so you don't have to tell anybody. So I've circled a number in the third row. I then cross off all the numbers horizontally and cross off the vertical numbers. So I am left with a single number, which I circle. What I'd like you to do now is to add up those 4 circles, the values of the 4 circles. Add them up, don't tell anybody. So here we go. And just like magic, but it's not magic, it's maths, we all got 28. Now the question is, why or how does it happen? I'm going to show you. Here we've got a number square, and this green patch here is where your numbers. But then the top line, those are 4 values. It could be any values you want, as long as they add up to 14. And down the vertical line, though again, those are any numbers, but they all got to add up to 14. You could use negative numbers, minus numbers. It's a good exercise teachers is using fractions. That's a great one. And what we have is an addition table. So 2 plus 1 is 3, 2 plus 2 is 4, 2 plus 4 is 6, 2 plus 7 is 9, and we'll do the bottom one, 6 plus 1 is 7, then 8, 10, 13. Then you get rid of the workings, and then you give those to the people. And if you follow the rules that I've done, they will get 28. And there are so many combinations we could use to get 28. So you could have a class with 30 different squares, but the answer will always be 28 in this case. Then if you're feeling brave, you might do a 5 by 5. So maybe create some puzzles for other people. We're now moving on to a very sad story. Yes, the story about my poor froggy. Now, before we do this activity, and it happened in this previous one, people think the answer is whatever it is very quickly, and they didn't put any thought into it. And when we're doing maths, all we need to do is look to see what is it all about. Try and work out what is the meaning of this? What are they trying to get at? What should I take care that I don't slip up? And there are ways of doing it by breaking it down into smaller bits, as we did with that 1 to 100. Or you can do it by creating a table like the clock. I've shown you the way they did the table for your number square. Or do diagrams, arrows and spots and all sorts. You don't have to draw beautiful frogs, just arrows and so on. So I don't want you to jump to the conclusion of what the answer is, because I know that answer is going to be wrong in 95% of the cases. So here comes the story of poor froggy. So dear poor froggy didn't read the warning sign and fell down the well, which is 12 meters deep. And we have to work out how many days it would take poor froggy to get out. And when poor froggy reaches the 12, then the frog can climb out. During the day when the sun is shining, the frog is very energetic and can climb 3 meters. And then when it comes dusk and it starts getting dark, the frog gets very tired and then hangs onto the side, falls asleep, and slips down 2 meters. The next day, refreshed with the sun shining, the frog goes up 3 meters. But sadly, energy disappears as it gets dark, falls asleep, and drops 2 meters. So during the daylight, it goes up 3 meters. During the dark, it comes down 2 meters. So after day 2, the frog is 2 meters high? Think before you shout out the answer. I would like you to work out how many days it would take the frog to get to 12. I'm going to go get the frog to climb up slowly, and you can keep changing your answer when you realize what's happening. So after day 2, it's at 2 meters. Day 3, it goes up to 5, it comes down to 3. Day 4 goes to 6, comes down to 4. Day 5 goes to 7, and comes down to 5. Day 6 goes up to 8 and comes down to 6. Day 7 goes up to 9, comes down to 7. Getting excited now. Day 8 goes up to 10, comes down to 8. Day 9, oh dear, doesn't quite make it, comes down to 9. And then day 10, the dear frog escapes. So very well done for those people who got it. And those problems are quite simple to, if you do it in a logical way. Do it in a logical way. So I don't know why I did that, but we are going to go on to that one. So we're going to do a little, well, it's not quite a card trick, but it's an interesting little trick. And there's a bit of maths behind it, of course. Cards are wonderful things. If I was going to a desert island, I'd always take a pack of cards, play games. You can create buildings with cards. Always great fun when I was small. So these are spelling cards. We're going back to another spelling lesson. So I'm going to spell out the words, and every time I spell out the word, the card with my fingers crossed will come up. So we go O-N-E, and we should get a 1. Then T-W-O, and we should get a 2. T-H-R-E-E, and we get a 3. F-O-U-R, and we get a 4. And then F-I-V-E, we get the 5, and then we get the 6. Now, I'm sure you're very wise and know that those cards were not random. They weren't random at all. I put them in a certain order so that would work. Your task this weekend is to get a pack of cards and try now work out what the order was. And then you can do it as a trick with your friends and so on. It's always great to have little magic shows at school, showing people your talents with cards. And then once you've done 1 to 6, then try 1 to 10. And then after 1 to 10, try all one suit, 1 to 13, which is Jack, Queen, and King as well. But have fun with that. It's not as hard as you think it is. And I've had lots of year 4s do it as well as older people. Now I come to my favorite activity, and that is cutting up paper. I love cutting up paper. It's all recycled, this paper, by the way, in case you... So there is a hoop. And with this hoop, I'm going to cut it in half. And as we know, the rules of cutting things in half is that we get 2 pieces. And just like magic, we get 2 pieces. I'm not a magician, by the way. I do mathematicians stuff. Now it's all to do with maths. Now we have got another piece. It's just a bit wider and it's got a line through it, so I don't cut crooked. Now this time, if you notice what I was going to do, I was going to put a half a twist in it. So I put a half a twist. Now, if you know what's going to happen, because you've seen this done before, you're not going to see some things you're going to see later you've never seen before, I'm sure. Don't tell anybody what happens. So here we've got a hoop with a curl in it. Now, this is a very famous shape. And it was sort of named after the person who did lots of study on shape and so on. And his name was Mobius. And this happened in the 1700s. And he's a German mathematician. And he played around with these shapes. We are lucky to have simple paper. He was using horrible material. So as we know, the rules of the world and maths is that if you cut something in half, I'm just worried about cutting the ink down there. Let's go back here. If you cut anything in half, you're going to get two pieces. And as you can see, we've got two pieces. Or have we? Two pieces? No, there's one piece. If I pull it along, there's one piece. One piece of paper. So there you are. Now, if you cut this Mobius strip again, something else happens. But we don't have time to do that because we're going on to another one. And this time, I promise you we're going to get two pieces. I'm sure you don't trust me anymore, but never mind. So here we go. Instead of doing half a twist, we do a whole twist. Do a whole twist. So it does look awful. Oh, it's terrible. Have extra tape here. So there you are. There is a Mobius strip with a whole twist. And we're going to cut it in half, and we are going to get two pieces. If I have an accident, it'll be more, but we're not going to have an accident. There we go. When I do this in school halls, I use much longer pieces of paper, and it's so much easier to cut than having corners to turn around with. Now, I've got a feeling lots of people have made Mobius strips this week. I don't know why, but we'll see. So here we are. We've got two pieces. The interesting thing is, it behaves itself. The interesting thing is, it's interlocking. It's like a chain. It's inside each other. There, you can pull it. It's a chain. So if you want to start some Christmas decorations, you just need a Mobius strip. So now, you thought that was fun. We now come back to an ordinary Mobius strip. The only difference is that the artwork on here is worth thousands of nothing. This is my lovely artwork. And we are going to cut this Mobius strip. This is just a half a twist. We're going to cut it in thirds. And so it so happens my masterpiece, is going to make it allow it to cut it in thirds. So here we go. And we come around here. And now we come to the beginning. So we're still going to keep going around. And It used to take a long time when you use a long piece of paper. And so here we are. There you are. It is the same as doing a hole twist. So you've got two hoops. But if you have a look, the smaller hoop is my coloring, my masterpiece, and the white hoop was the outside. And because I cut it in thirds, this is 1/3 of that. So that's 3 times as that in length. And so finally, oh yes, there's something more. We have got a Mobius strip and a hoop. And the hoop has been put at right angles to the Mobius strip. So what we're going to do is we're going to attempt to cut the Mobius strip. And again, when I do this in the halls, I have nice big long pieces of paper, but here I struggle a bit because of the screen. So here we go. Now we're going to go through the hoop, cutting the hoop in half. And as you can see, it's a mess. But we haven't cut the hoop yet. So we're going to cut the hoop. And here again, I use 3 or 4 people to, oh, this is not bad. And look at that. I have created, or the paper has created, a square. A square. There you are. The world of Mobius. And I promise you, you will enjoy doing all the sorts of things. And of course, there's tons of things to do on the internet. Young mathematicians, I'm afraid that's the end. And I thank you for your support. And I thank the teachers for logging on and getting going. And so I'm going to end off with a 20-second or sort of say a minute little video of 3-dimensional drawings, but also they are optical illusions. They're called amorphic diagrams, and they're good fun. So it's to sit back and relax and watch it. Impossible cube. Whoops. That's it. And remember, young mathematicians, maths is not just in the classroom, it's all over the place. A lot of exciting things to do. Have a good weekend, and hopefully we'll see each other live next year.